Hi, good day. Let's continue our Golang journey from the point of view of the C# developer. Today we're going to be looking at concurrency in Go, and as usual, let's look at a C# program which has some concurrency in it, and let's convert it into Go. So on my right, I got an array with a list of all API URLs, and we're going to run it through them, and we have a method which checks if the URLs are responding, and we're going to call them asynchronously, and then do a task.waitAll and wait until all the tasks are finished. So to run that, let me clear. So we start checking concurrently all the variables, all the URLs, and then we get the responses printed out. Let's do that in Golang. To start with, we're going to define an array of APIs. To do that, API colon equals to an array of string, open close curly braces, and we can pretty much copy the list of APIs. There you go. And then let's first create a function to check the API. So func check API, and it's gonna take an API string, open curly braces, and we are going to be using HTTP package to check the URL. So the HTTP package returns two variables back. So we are not interested in the first value. We are error and http.get and the API. So if you look at the HTTP GET package, it returns both an HTTP response as well as an error. We don't particularly care about the HTTP response itself, so we are ignoring it by using underscore. And here we can say if error equals to nil, then we are good. fmt.println, we can say okay for that API. Else we can say fmt.println, we say bad for that API. And so I'm missing a colon there, so that's why I'm getting a squiggly line. Let's do another print statement at the very beginning of the func, so we know we are checking for that. Okay, let's have a for loop and run it through the loop. So for, so we don't care about the initial variable, so we just basically say for, comma, and semicolon, I less than len of APIs. So it's APIs. Actually, we don't need length here. We'll just range over the APIs. So r and comma API equals to range over APIs. Okay. So now we basically call the check API method. And that's colon equals to. Here you go. At the moment, we can actually run this. There is no concurrency at the moment, so it's going to do it one by one, checking, making sure it's okay, checking, making sure it's okay. So there's no concurrency yet. And to make it concurrent, all we need to do is prefix the Golang verb go before calling the method. Now, if you run it, you're not going to see anything. That's because, like in C#, the program itself is finishing before these functions had a chance to finish. So to do that, we need to do something very similar to what we have in C#, which is like a task.waitAll. So to do that something similar in Golang is we first need to create what's called a wait group. So we first need to define a wait group. Var wg sync dot wait group, and then we say wait group dot add how many tasks we need to add to the wait group. So for us, it's just going to be a length of APIs. So we need to wait for each of the APIs. And what we can do is then we do at the very end of the program. So we say wg.wait, which is equivalent of our task.waitAll. But when we call this function, we need to say wait group.done. So we can pass the wait group by reference to this function and then let that function do the wait group.done. So for example, I'll just do it, but we're not going to do that. So we can do something like this. So we can say wg star sync dot wait group, and you can say wait group dot done here. This would work, but it's not best practice. You don't really want this function to know about your wait groups and what you're waiting for. So to go around that, we'll create an anonymous function. So to create an anonymous function in Go is basically go func and open curly braces, and that's an anonymous function in Go. And we will call the anonymous function using concurrency, but we would just call the API itself as it is. So we need to execute at the moment we are only defining the anonymous function. So to execute it, this is very similar to JavaScript's immediately executed function. So we will have to execute that. And now we see an yellow squiggly line. So what it's saying is the loop variable API captured by func literal, because now we are entering into the world of closures. So we are passing the API, which is part of this loop, into an asynchronous task. So to avoid any confusion about what we need to do is we are better off creating a local variable. So let's say URL to check, I'll just say API to check equal to API, and then we'll pass the colon equals to, and we'll pass the local variable to the function here. So copy and paste. So now we got rid of the squiggly line because we are using a local variable. There is no confusion about this. We are getting rid of the errors, so we know exactly. We have a copy of the API to check, and that's what's getting passed to this function asynchronously, right? So that's pretty much it. So once we have done, so we need to say wg.done. So let's run this, and we will go through this again, but just run this and see how it works. So now if you see, all the checking happens simultaneously. All these check API methods are kicked off simultaneously, and the responses are getting printed as and when the check finishes, right? So let's just go through this one more time, right? The function itself hasn't changed. The function itself doesn't have any asynchronous concept in it. It doesn't even define await async at the function level. We make this function asynchronous by the way we call it. And to call it, we use an anonymous function because we want to wait until all the tasks are finished. So we didn't want to pass the wait group pointer into the function itself because we wanted the function to be pure. We wanted the function to just do its thing. It shouldn't be aware of tasks, whether we're going to call it synchronously, whether we're going to call it asynchronously. So we created an anonymous function, and within the anonymous function we are calling the check API method, and we are saying WaitGroup.done after we have finished checking the API. And we are calling the anonymous function itself asynchronously by using the go keyword. So that gives us an equivalent of what we have done in C#. But you see at the top I have written something here which is something. There is a blog post about this. If you search for this and Golang, you will see a blog post by one of the Golang creators. What they say is, do not communicate by sharing memory, instead share memory by communicating. So what does it mean? We look at it with an example, right? So at the moment, the check API method is basically printing good or bad on the console. Let's say we want that reported to the calling method instead of just printing it on the console, right? So this is where Golang has a concept of channels. It doesn't have an equivalent concept in C#, so this is where Golang really shines here, and this is one of the reasons Golang is one of the more popular languages right now. So we are getting into the more interesting stuff of Golang. So Golang has a concept of a channel, and channel is the way asynchronous task can communicate with the calling method asynchronously. So let's see how we do it and convert this to use channels. So to do that, we basically have to first define a channel. So to define a channel, so let's say ch colon equals to, and we use the make keyword and say chan and string. String is the same as returning task of string. So if I do this, it is, what is that? I don't want to change this now. It is basically similar to that. We want this channel to be able to accept strings. So this can be int, this could be anything. So this could be any type. This could be a struct. So for now, we say let's do string. So we are defining a channel, and we are using the make built-in function which allocates and initializes an object, and we are making a channel which accepts a string. And one thing, whenever we need to do, when we make a channel, we need to say channel dot close. Close channel, but we shouldn't close it right after we create it. We want to close it when we don't need it anymore. And Golang makes it very easier, as we saw in my last video. The defer keyword, make sure we don't have to worry about at what point we are ready to close the channel. We just say defer close channel, and Golang will take care of it for us. When the method finishes, one of the last things it's going to do is make sure the channel is closed. So that's out of the way. So we don't really have to figure out where we need to close it. We just go very Lex9 defer close channel when the method is going to be finished. And so okay, now so in the check API method, when we are calling the check API method, we need to pass the channel in, so the check API method can communicate with the parent using the channel. So to do that, it's basically like passing another variable parameter to the check API method. So ch chan, and it's going to be a string channel type. And here we can say, to pass it, we're going to say ch. Now, at the moment, we haven't really, so now what do we need to do next? So we need to, now we can communicate with the parent using the channel. So what we are going to do is we're going to convert all the fmt.println statements. Instead of just printing it on the console from within the API, we are going to communicate with the parent using the channel. So to do that, all I'm going to do is say ch arrow towards the channel, and instead of fmt.println, we are going to say sprintf. So sprintf is returns it returns a string, and we can it gets passed on to the channel. So we are going to say sprintf, and then we can say we have to use checking colon and percentage yes and API. So we are going to using this string interpolation. So we are saying percentage yes, and we are passing the API for it. And likewise, let's just go convert everything. So we say, let's copy that. And everywhere we are doing fmt.println, we are going to make it to sprintf. And we are going to say percentage yes and percentage yes. So here you go. So we are converted from simple printlns to sprintf. So that way we are communicating with the caller using the channel. Okay, how does the caller receive the channel information? So to do that, we need to have a loop. So for I equals 0, colon equals to 0, semicolon I less than we will come here. So so how many messages are we going to receive? So for every method we are calling, we are going to get at least we're going to get two messages. One's for checking and one is the actual response back. So we're going to get len of APIs times 2 messages. So we have 1, 2, 3, 4, 5, 6. So we're going to get 12 messages back. And I plus plus. And then we say fmt dot println, and we receive the message. So arrow towards the print. So this is where we receive the messages from the channel, and that's the way we send messages to the channel. So the arrow pointing towards the channel and the arrow coming out of the channel. And so that's pretty much it. Now let's try. So here you go. So we are communicating with the calling method using channels. These are really, really powerful. So let's look at what we said here. So do not communicate by sharing memory. Instead, share memory by communicating. So in the .NET, using pure threads, remember we would have the lock. We would have an object, we will lock it, and then we would make sure one thread is accessing that object only at the same. It's not accessing it concurrently. We need to make sure the access is done by only one thread at a time, so we have to lock it, and we do all this. Instead of doing all that, what we're saying is we will share memory by communicating. So we are not sharing memory. So there is no lock. There is no single object or variable which is going to be accessed by multiple threads at the same time. But we achieve the same results by sharing the information we want to communicate with the other threads. So it's a very good blog. I would recommend you go read this. I will try, and I'll get the URL and added it in the description below. And that's pretty much it. So let's go through this one more time, because this is getting into the nitty-gritty of the Golang language, and this is one of the most important concepts we need to understand in Golang. So what have we done? We have a list of APIs, and we're going to define a channel for communicating with the child tasks to the parent task, and we use differ close channel because we want to make sure the channel is closed when the program ends. So using the Golang's differ keyword, we are able to do that straight away when we're defining the channel. And then we define a wait group. We need to define the wait group because we need to know when all the child tasks are complete, so we can wait for them. And we add the number of tasks we want to create. So the number of tasks is equal to the number of APIs we need to check. So we are going to call that many, we're going to call the API that many times asynchronously. Then we range over the APIs and we copy it to a local variable because we don't want to use the loop variable in a closure. So copying it to a local variable makes it safer to pass it to a asynchronous method, and we use an anonymous go function because we want to identify when the task is finished. We want to do that because we want to call wg.done when the check API is finished. We didn't want to pass the wait group into the check API function because we wanted to keep it pure. We didn't want the check API function itself to know whether it's being called synchronously or asynchronously. That is not check API's requirements. It just needs to do one thing, and that's what it does. And to communicate with the calling method, we pass a channel, and uh, check API is going to write to the channel to communicate to the parent. And when the check API method is finished, we are going to call workgroup.done, and that then the wait group knows it's finished that many tasks it's supposed to finish. And then we are receiving the communication from the channel. So we basically calculating how many messages we want to receive through the channel, and we say fmt.println ch, and finally display it out in the console. And finally we do a wg.wait. We don't want the program to end before all the tasks are completed. So I would recommend you try this on your own and play with it. We haven't covered a lot of Golang concurrency concepts. I'm trying to keep it simple for the initial video. We will come back and look at more complex scenarios in a later video. Thanks for watching. Uh, Please subscribe to be notified of any new videos instantly. And as usual, you will find all the source code in my GitHub repo. Thank you.